Section 4.5, dilations. Our essential question, what does it mean to dilate a figure? So first thing we define is a dilation. Dilation is just transformation that enlarges or reduces a figure with respect to a fixed point. If you think of going to your eye doctor, when they dilate your eyes, your pupil gets bigger, right? That's the same word. The center of dilation is a fixed point of a dilation, so the point that it's a reference to that it's getting larger from. A scale factor is a ratio of corresponding sides of the image and the pre-image. Okay, so this is basically normally written as a fraction that shows the relationship. There are other ways to write it, but it cannot be written as a decimal. At enlargement, the image gets larger, so your scale factor is going to be greater than 1. So for example, 3/2 would be an enlargement. Your reduction, the image gets smaller, so your scale factor is less than 1, like a half. So then example 1 is asking if we're doing an enlargement or reduction and the scale factor. Now, this is a little hard to see what's going on here. This is actually a pencil here, right? So I have a pencil here, P, and a pencil here, P prime. So just looking at that, I can see that it's getting larger. So that's going to be an enlargement. So that encourages me on how I'm going to write my fraction. So here, this is 6, this is 10. So my scale factor is going to be 10 to 6. We always reduce that. So my scale factor is 5 to 3. On B, what we have here is these are two erasers. So I have P and P prime. So that's clearly getting smaller. So it's a reduction. And my numbers are 11 and 22. So I do 11/22, which reduces to 1/2, which is my scale factor. On the next problem, we have two triangles there, P and P prime. It says find the scale factor, tell whether the dilation is reduction or an enlargement, and then find the value of X. I would say these instructions are a little backwards. It's easier to see if it's a reduction or enlargement before you set up the scale factor, and then you know how you're setting it up. So if I look at P and P prime, right, as I go from P to P prime, it's getting bigger. So I know that it's an enlargement. So I have 14/6, which I reduce to 7/3. Okay. And then X is this part in here. So 14 minus 6 gives me that is 8. Okay. That is not really a helpful number for anything that we do, but they do ask for us to solve it. The 14 and the 6 are what I care about. This is my center. So the distance from my center to my first picture is important. And the distance from my center to my last picture is important. But the distance in between them doesn't really affect anything. Turning the paper over. Okay. Example 2. Right. Says graph the polygon and its image after the dilation with a scale factor of K. So they give me my points here. My scale factor is K. The black image here is my original. The red is my new one. And what I did is I just took the 2, I multiplied each point times 2, and that got those points. And they don't tell you this, but this is considered to be around the origin. If we did a dilation, and we won't really look at these, if I did a dilation around a specific point here, it would move away from that point. So if I did a dilation from like S, then this would start at S, wouldn't move, everything else would get bigger around this. So if I took that red one and started it, had this S and that be the same, that would be around point S. Okay, most of the ones we're going to do are going to be around the origin. B, right, they give me different points here, which again is our black. And then they say K equals negative 50%, right, which is a scale factor of negative 1/2. So it's going to get smaller. The negative flips it. Okay. So if I multiply these points by my half, I get my new points here. And if you notice, AB here matches with A prime, B prime here, right? BC here matches with C prime, B prime here. Okay, that's because of the negative, it flipped what it was doing. Then example 3 asks us to do two things. So example 3 says the vertices of KLM are negative 3, 0, negative 2, 1, and negative 1, negative 1. Graph the image of KLM after the given composition. So that means we're doing two things. So I graphed KLM. They then asked for the translation. Plus 4, plus 2. So this is my new part. Okay, that one's not drawn in here. They don't ask for it. So if it helps, you can draw that in there. But that is my K prime, L prime, M prime. And then dilate the center of the origin with a scale factor of 2. So I'm just doubling these points. I get this as my new point and graph that out. That red is my image after the translation and the dilation. And that is the end of 4.5 on dilations.